Alrighty. Well, this is an unusual hour for me to be doing one of these things pretty late. I was on a road trip, so I'll try to do my best here. I did look at the problem when it came out a little earlier. Thought about it during the road trip, but it's hard, so I'm not sure if I actually came up with a solution. I think this was actually a contest problem because I've attempted it before, but I haven't checked what I did, but obviously I didn't solve it. So you're given a string num, which is digits, which has digits is a sum of digits is balanced if the sum of the digits at the even indices is equal to sum of the digits at odd indices. Return the number of distinct permutations of num that are balanced. Mod 10 to the 9th plus 7, because there could be a lot of answers here. Okay, so example here, 1, 2, 3. There's two ways of writing a permutation that's balanced. Since the sum is 6, the odds and evens need to add up to 3, which is half 6, so it should be like 1, 1, 3, 2 or 2, 1, 3. Yeah. 1, 1, 2, there's only one way, that's 1, 1, 1, 2, 1. And then this thing, there's no ways because this adds up to an odd number, and you can't have a split where it's odd, or it will add up to an odd number. So I think maybe that's going to be just simple case of impossible odd sum. So first I'll convert it to a digits array where it'll be integer of the k character for every k character in num. And if the sum of those digits, let's say that sum is let's say capital S is the sum of the digits. If the sum is odd, then return 0. Otherwise, return 1. Just making sure that that works. Yeah, that works. Okay. So I was thinking about how to actually do this on the trip, and the first thing I thought up was first thing I thought was basically you have two buckets, like a bucket of odd indice digits and a bucket of even indice digits, and those buckets need to add up to the same total. Actually, let's see, digits. And it doesn't really matter the order that the digits come in first. Like the number of permutations is going to be same if it's 112 versus 211. So actually I'm going to go ahead and sort the digits here. So what was I thinking? So I was thinking of using the simple case where you had 1122 0011223344, and if you think of these as the digits and these as indices, indices being 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. If you were to methodically go through all the possibilities, you would start by having indices that are like 0, 1, 2, 3, 4, and seeing the sum of the digits at those indices. The sum of the digits of those indices being half the total sum. So actually, let's say, I'll say h equals s divided by 2, which is the required half sum of each odd even set of indices. Maybe I should call this half. So if you think about just handling the indices, because indices are easier to backtrack in my mind, this is definitely going to be a backtracking algorithm, where you have certain indices that you're using and you will backtrack and use different indices once you've explored all the possibilities of one set of indices. So so how to do this? So let's say you have your set of, let's say you have, let's say you have a bag of indices. And let's say you have your numbers in that bag that's an array. Then for no, wait, what am I doing? You have your numbers. Let's say indices. Let's say you have a total of the value of those indices. Okay, and you have, okay, so I have this more thought out in my head on the trip. What I need here is, a way to know which indices to go to. So for instance, if you were to do 0, 1, 2, 3 as 1, 2, 3, 4 as your indices, which maps to 0, 0, 1, 1, 2, the next thing that you would do once you have your indices matching half the size of the array, you see the total. In this case, the total is 4, which is not equal to half the total sum of the digits, which is 20. So this is not going to work. So you would remove the index 4 and try 5, except 5 is another 2, so you'd actually try 6, which makes this, you try 1, 1, 3, and then you find that the sum there is 5, which is not 10. So you backtrack and try index, well, 7 is another 3, so you actually try 8. So that'd be a 4. That doesn't work. So basically when you backtrack, so here's the key point. When backtracking to try a different index, do not use the same value. So go to use the index of the following value. Else there will be redundant calculations or computation. So you don't want to try the indices of the things that are the same value as the things that you're backtracking. So I think what I'm going to do is I'm actually have a next index, which is going to be storing the index to use for the for the first value that follows the current value. So for instance, if these are the indices, the next index, the next value would be something like, the next value of 0 is going to be 1, and the next value of 1 is going to be 2, the next value of 2 is going to be 3, the next value of 3 is going to be 4, the next value of 4 is going to be something that's not there, and the next index, which is the first index, to use for the following value. So the next index would be so for zeros, the next index would be the first one. So that'd be 2. The first ones, the next index would be the first 2, which is 4. 3 would be 6. 4, the first 3, the first 4 would be at index 8, and the next thing after 4 would be like -1 or 10, something out of bounds. So I'm going to go, so for every index in range, okay, so I'm going to say the current value is the last value of the digits. And I'm going to say for every index in range n, where n is the length of, no, for every digits, yeah, actually n is the length of the digits. I'm going to go backwards. Current value is the last value. Next index. Say following is going to be -1. If the value, actually it should be n minus 1, -1, -1 going backwards through the array. And this is, let's make this -1 times n. So if the current value at this index, which is digits at this index, matches the current value, then the next index at this index is equal to the following. Else current value equals this, the digits at this index, and following is equal to index plus 1. Actually, I think this should be something like this. You're always going to set the next index to the following. And this should be negation. If the current index doesn't match, then you change spots. Okay. I'm going to just make sure this next index thing works like I thought it should. Okay. So we print out the digits. Okay, so yeah, I think this is right. So 1, if I want to go to the next number, which is 2, the index of that is going to be 1. 2, the next number is going to be 3, the next there is going to be 2, 3 goes to -1, the next number after 1 is 2, which has index 2, next number after 1 is number 2, which is index 2, 2 is -1, this is the trivial case. Let's go ahead and do one where I use 4321 0 432 1 0. Okay, yeah. 0 0 1 1 2 3. That's the sorted digits, and these are the digits of the first spot where the following number is. Okay, so then what I'm thinking is I need to actually do the backtracking. So the indices is a set of array, you have a total. So for each index in range n, well, I think I need something called following again. Following is going to be 0. Okay, so I think I want to call this add index. So what I'm thinking here is I have a for loop. It's going to go through how many times does this go through? Actually, I'm going to make this a while loop. Just make this while true. So each time I do the loop, it's going to either add an index. It's going to basically, so this is the each loop will generally add a number to the 1/2 like odd / even half. I'm not sure how you should describe this. Each loop will generally add a number to the current bag half, where a bag half is the digits in either the odd or even indices. So here, the first time, so in the general case, it's going to be if the add index is not equal to -1, indices is going to append this add index, and it's going to generally add the next index in the array. If it's not equal to -1 or n, okay. Now if I do, actually that's not just it. Add indices, we'll also need to add it to the total, whatever the value is at this index. So it's going to be digits at this index. Okay. And then let's say I have a size, which is the length of my indices. And if I'm at the half size of the total length, then I need to actually check if size is not actually okay. This is I'll make a note here. Note currently working on even length num array will need to fix / handle odd length arrays. Like I'm assuming that the number of digits I'm dealing with is something nice and evenly split rather than like 5, 4, 3, 2, 2, 1. Alright, if size times 2 is equal to n, then this thing needs to check if the sum matches half of total of total sum of all digits. I think okay, then I think I'll need to work on that a little bit later. Is that right? Okay, so actually I think I might need to work on it now. If size times 2 equals n, then I'll do if total equals half. Actually, maybe I should capitalize this. Then I need to calculate how the current indices add onto the answer count. Okay, yeah, I think that's also needs to be done. Okay, so the backtracking is the main thing that I was thinking of. So after you calculate that the total is half, then you need to pop. Then you'll need to say add index is equal to -1. Okay. And when add index is -1, that means that here I think this is where you need to remove indices, remove last index. Oh my god. Okay, so say last is equal to indices dot pop, and then add index is equal to next index of the last index. Yeah, I think that's what I want. So for instance, if I have the digits be these, it starts with 0, 1, 2, 3, 4, and it checks the sum there. So these are the indices, and the values would be like 0, 0, 1, 1, 2. So when it when it finally hits the end, it's going to pop the 4, which means that it needs to replace the 2 with something that is the next value that it wants to attempt, which should be a 3. So when it pops a 2, where 2's index is 4, the next index is going to be the next index should be the index that I find in the next index array at 4, right? 0, 1, 2, 3, 4. So it should be 6. So I'll try 3. And then when it does that and finishes it, it checks, it pops the 6, and it does 8, which is the index at 6, which is there, which will be tempted for. Okay. So I think this is actually here. It's actually both here and here. Now if I do add index -1, that can be used as an indicator that I just want to pop the last element. Yeah, if it's an impossible index to add, then it's going to remove the last value in the last indice and then try to add on to it the next index. So okay. Let me actually, so I'm not going to be able to, I don't think it makes sense for me to try to do the calculation completely right now. I just need to print out all the things that it finds to be correct. So if the total equals half, then I'm just going to print my digits. No, I'm going to print out my indices here. If the total is half, print out my indices. And when I pop an index, I need to remove the element as well from the sum. So total minus equals the digits at last. And then add index is going to be that. Print out the indices. And let's say I actually find the values is going to be digits at k for every k in indices. I'll print out the values there. Okay. I mean, I don't think this is going to run, but we'll see how it goes. Okay, add index. Not equal to n. Index out of range. Oh, I don't want to try the case where it's odd number of digits quite yet. Oh, this can go infinite. This never breaks. Oh shoot. When is this supposed to break? Size equals length of indices. Size times 2. Total is half. Actually, it should be When is it supposed to stop? It's supposed to stop when there's no more indices to be added. While true. Alright, I'm going to do a for loop here for j in range 100. Let's see how much what does in this. If add index equals -1, so what is it doing? List index out of range here. It's not actually doing anything, I think, because it's not printing anything out before it crashes. So the first add index is 0. So it should say that the size is 0, which isn't half of n. So it should be going to here. So indices.append 0. Total would add 0. Next add index is 1. And then here size is going to be 1. 1 times 2 is not 5. Or not 10. So it's going to do this. So it's going to add index 2. I'm really surprised that this is crashing in this fashion. Print indices, maybe? Oh. It doesn't. So adds 0, it adds 1. Oh, fuck. This is another odd case. I don't really want to work on odd cases right now. Okay. Wonder if this thing still crashes. I don't think I want to print out the indices. Well, it's not printing anything out if I don't print out the indices. What the hell? Okay, so what's going on with this case? So it does 0, 0, 1, 0, 2, 0. Okay, it does 0, 1, 2, 3, 4. That's good. And then the next add index should be -1. So when it adds the -1, let's go ahead and print out also the sum here. Okay, so 0, 0, 0, 1 indices matches to 0, 0, which adds up to 0. 0, 1, 2, 0, 0, 1, which adds up to 1. This doesn't seem right. 0, 1, 2, 3 should be adding to 2, I'm pretty sure. Total. Alright, fine. Let's go ahead and actually see the values as well. So when I add onto my indices, I'll add onto my values. And then I'll append here pop. Last value is going to be values.pop. And delete the last value from the total. Indices, values, total. What is going on? Okay, values are 0, 0. The values became 0, 0, 0, even though the sum is 1. Am I adding the wrong values? Values append. Oh my god. Add index. Okay. Total digits at index. Okay, okay. Plus equals versus equals. There's a difference there. Okay, there we go. So it tries that. 0, 1, 2, 3, 4 adds up to has the value 0, 0, 1, 1, 2, which is sum to 4. If the total is equal to half, which it doesn't do any of this stuff. Now the add index is equal to -1. So the next iteration it should do, if the add index equals, it's supposed to be an and. If the add index not equal to -1 and the add index not equal to n. Yeah. That's a negative. So why doesn't it pop? Okay. Add index is -1. If add index is -1, so this should be false here. So print trying removal. Not really trying the removal like I thought it would. If add index not equal to -1. Okay, so actually size is 5. N is the length of digits, which is 10. So what is this? Why doesn't this hit right here? Size times 2 is equal to n. This is hitting cap on bag length. Okay. It's getting there. So it's definitely adding -1 as the add index. If this is, so somehow this is, if it's not -1 and it's not equal to n, but it is equal to -1. So why doesn't it, am I just screwing up my if statements somehow? If add index is equal to -1 at this point. Okay, let me go ahead and we're going to add index in the loop print. Okay, yeah, the add index is -1. It's, oh my god, I see. I see now. It's just continually hitting this if statement. because I don't actually pop anything here. So what does that mean? It means I need to, if I do 0, 0, 0, 0, 0, 1, 1, 2, I say the next number is negative 1, then do I need to immediately pop before I check for the end condition? That can't be right. Do I need to pop right now? If I pop out the 2 now, maybe I need to pop the 2. Maybe I need to actually determine what the add index is, yeah. Yeah, but that would be the same code as this thing right here. Okay. Maybe there's a better way of doing this, but I'm kind of whatever here. Okay. Yeah, now I just did both things. Okay, so I need to do one or the other and not both. Yeah, last index. Last, pop it, total, remove it, add index equals that. Okay, actually this is the first time it's actually trying the removal. So yeah, this is popping from empty list. That's when it's actually not working, or when the while loop should stop. Yeah. So if I'm trying to remove something where there is nothing to remove, so if the size of the thing is 0, work. Okay. Alright, this is a little verbose in the printing. Print hitting the cap, move that. The indices, print the values. I'll say this is a special. Okay, so what do we have here? So does it ever reach special? Oh yeah, it does. 2, 4, 4, which is 10. Great. And 0, 1, 1, 4, 4, that's 10. Good. 0, 1, 2, 3, 4. Excellent. 0, 2, 2, 3, 3. Good. 1, 1, 2, 2, 4, 10. Okay, so it is finding the correct kind of bags that add up to half the thing. Okay, so the next step is calculating the number of ways these things can occur using a little bit of number theory and combinatorics, and also Also, somehow keeping track of things in terms of counts, because you know the counts of the things rather than the actual numbers to do the combinatorics. Okay, so is this fine, or do I need to actually fix this code up a little bit? This is a little disgusting to have the same code like this copy pasted. I could set the add index to -1 here, and then not have this continue, and have it just fall through, and maybe that can handle it actually. So I'm going to try that. Add index equals -1. Remove this. Have it not continue, and then have it just progress through this stuff. So it's not going to be true here. And so it should go through here. Yeah, let's try that. Okay, I think that still worked similarly. Yeah, so still finding the correct stuff. 0, 0, 2, 4, 4, 0, 3, 3, 4. Yeah, okay, I think that actually is sound. Hopefully. So the next step is combinatorics, maybe. So what I'm going to do is I'm going to have a frequency, and this is going to be 0 times 10. This is going to track the frequency of the digits in the bag. Okay, so for instance, if it's something like this, the bag has a frequency of 2 for 0, 1 for 2, and 2 for 4, and 0 for 1s and 0 for 3s. The number of ways you can rearrange this is so in terms of combinations, or so for permutations with repeated or with identical values or repeat values, the number of ways that you do that is equal to n factorial divided by r 1 factorial times r2 factorial, r3 factorial, where r1 through whatever to r is the frequency of repeats. So for example, if you have something that is 1, 1, 1, 2, 4, 4, 4, yeah, 1, 1, 1, 7, 7, and let's say there's 5 6s. The n is going to be 3 plus 2 plus 5, so that's 10. And the number of repeats of 1 is going to be like 3. The number of repeats of 7 is going to be 2. And the number of repeats of 6 is 5. So you can calculate that as 10 factorial divided by 3 factorial, 2 factorial, 5 factorial. Technically, that's one way of calculating it. but also the way that I'll probably be calculating is for also can be interpreted or can be counted using combinations, where you have, if you have that same, there's going to be 10 spots where you choose groups of spots for 1s, 7s, and 6s. So this could be calculated as 10 choose 3 times 7 choose 2 times 5 choose 5. So this is equivalent to like out of 10 spots, choose 3, 4 ones, and then out of 7 remaining spots, choose 2 4 7s, and then out of 5 remaining spots, choose 5 for the 6s. When you do the combinations there, the ones, like, they're identical, right? So it's all, it doesn't matter the order of those ones. So if you just know how many 1s there are, how many 7s there are, and how many 6s there are, then you can do the calculation. So it just depends on the counts. So I think here, if I keep track of the frequencies, so for every value that I have, when I add that value to my indices, and when I add the values, I add the frequency here. So say the value equals indices at this at index. Add the value to the values list. Add it to the total here. And the frequency of this value is incremented by 1. And then also when I remove it, I will say the frequency of this value is decreased by 1. And then if I pass, so if this is a special working one, then I'm going to, let's go ahead and define a function here. Fine. Do I need to create this answer as this instance variable? Whatever. Add count, the frequency. So this should be something like for, let's say count is 0. Actually, I think count should be 1. For every f in frequencies, let's say size currently is going to be digits divided by 2, n divided by 2, and for every frequency, if the frequency is 0, then continue. Otherwise, you're going to do, actually I keep on forgetting how to do combinations in Python. Math.com nr. Okay. So count should times equals the number of ways you do this size. Size, choosing this frequency, and then size minus equal to frequency. Yeah, I think that's right. And then after this, you'll say answer plus equals count. Let's go ahead and print out the answer. This is definitely not correct, because then you need to actually calculate like the number of ways of doing this bag, and then the number of ways of doing the other bag, and then multiply those two bags. Like if one bag is 00112, the other bag should be no, sorry, that bag doesn't work. If this bag is 00244, the other bag should be 11233. That adds up to 10 using the other numbers. And then the number of ways of doing this bag times the number of ways of doing the other bag should be the actual, like, actually the number of things that you increment to the answer rather than this thing. But I just want to see that this works on one half of it. So I should probably just make this like return this thing for now. Actually, I'll just rather return it. I'll say print frequency and count. Oh, I need to call this function. When did this go out of range? 0, value equals indices. Whoops, this should be digits. This should be add count. Did I misspell things? Frequency. The array is called frequencies with an S. When am I not doing frequency? Holy cow. Print out the frequencies. Oh, out of range. Total minus equals digits at value. Oh boy. Definitely staying up too late. N must be a non-negative integer. Oh boy. Size is n divided by 2, so it should be 5. And then, interesting. So when does this crash? So what is it doing here? 2, 3. Size, so this is, so size is 4, or n is 4, size should be 2. So for every frequency, Alright, let me go ahead and print it here. So the add, oh, whoa. Frequency should never be negative. How is that somehow negative? So I added the value. When I add the value, I add 1 to the frequency of that value. When, oh my god, I'm so stupid. Should be lost value. Okay. So what am I looking at here? So, does this work? 1, 4, sure that works. So that adds up to 5, this thing adds up to 10. And I'm returning, am I returning? Print, okay. Counted. Okay, so if you have a 1 and a 4, there's 2 ways of rearranging that. That's 4, 1, or 1, 4. That's kind of trivial. And if you have 0, 0, 2, 4, 4, 4, 0, 0, 2, 4, 4, so it's 5 choose 2, which is 6, I want to say. No, 5 choose 2 is 5 factorial, 2 over 2 factorial, 3 factorial. Or it's just 6 times, or 5 times 4 divided by 2 times 1. So that's 20 divided by 2, that's 10. 5 factorial over 3 factorial, 2 factorial. 5 times 4 over 2 times 1. Oh my god, why am I so stupid? 5 choose 10. Okay. So it's 5 choose 2, which is 10. And then 3 choose 1, which is 3. And 2 choose 2, which is 1. So yeah, there's 30 ways of doing that. Same deal here, 2, 2, 1. Oh yeah, everything that's 2, 2, 1 is going to be 30 ways. If it's all ones, then there's 120 ways. It's like same as a permutation of 5 different numbers. Okay, so I think this is actually counting it correctly. Okay. So next up is when I have the half count, I need to multiply the number of ways of doing this versus the number of ways of doing the complement of this, the other bag. Oh, God. So if I have my indices here, then I need to get the, okay. Is it just going to be straight multiplication all the way around? So for every frequency, f in frequency, I think it might just be like calculating the, I think there might be a simplified calculation here, but I'm just going to do the hard coding of it, hard coding of the other way. Okay, so I'll say that there's going to be the other frequencies, and this is going to be I think I need a total frequencies here, and this is going to be equal to counter my digits. Go ahead and just print out that to make sure that's working here. Okay. Yeah, I think that's what I want. So the other frequencies is going to be um, I want this thing to be, it's not going to work if there's no actual value for it, for some missing numbers. It's going to be 0 if k not in total frequency, else else total frequencies at k minus frequencies at k for every k in range 10. Okay, I think that's so convoluted. So the other frequencies, so 0 for every digit from 0 to 9. If that's not in any of the digits, then it's 0. If it is, then you take the total that there is minus the frequency of this thing. Okay, let's go ahead and just see if that is actually something that's reasonable. Didn't crash. It's also not printing it out like I expected it to. Let's just call it. Oh, am I not? So it's actually printing out, but I don't actually have any labeling for it. Okay, so here it is. So if my frequency, so here it's 2 zeros, 1, 2, and 2 fours. So it's going to be 2 zeros, 1, 2, and 2 fours. And my other frequency should be 0 zeros, 2 ones, 1, 2, and 2 threes. So 2 ones, 1, 2, 2 threes. Yeah, okay, so I think that's correct. So I'll say my other count is starting with 1, and for every frequency in frequencies, no, for every frequency in other frequencies, if that frequency is 0, then just ignore it. Otherwise, the add count is going to times equals math.combinations of size f. I need to reset size to be n by 2. And then size recommended by f. And now I actually say that the total number of ways that this occurs is going to be it's going to be count, add count, and then count times add count. Oh, this should be other count. What am I doing? Other count. All right. So okay, 0, 0, 2, 4, 4. So it should be 2, 2, 1 for both the ways of doing each. So it should be 30, 30, 900. And then so 0, 1, 2, 3, 4 from one bag, 0, 1, 2, 3, 4 the other bag. So it's 120 each way. I think these are all kind of very simple calculations. There's no variation in this. So 1, 1, 2, 2. So there's two ways of doing 2, 1. And then there's another two ways of doing 1, 2, 1. So that's 4. This is also currently being redundant in terms of doing both bags. Like it does the bag that is 0, 0, 2, 4, 4, which has a complement that is 1, 1, 2, 3, 3. And it's also doing the 1, 1, 2, 2, 3. Like 1, 1, 2, 3, 3. Like it's doing both calculations, so it's doing it 2 times. So I need to stop that. Okay, so I need to stop that. So how do I detect when to stop it? I think when I was thinking this through, there was like a halfway point. The halfway point is at some point the other bag is a bag that's already been done. So if I track that I've done the bag that is 00244, and if I do the calculation for the other bag and the other bag ends up being 00244, then I know that I don't need to do it. So if I just keep track of a tuple that is the frequencies of the bag, and I check to see if the other bag is that tuple. I don't think it's great memory-wise, storing all these tuples, but there could be other ways of handling this. Is there better logic than that? Oh, I was thinking if I do a comparison of the two tuples, if the other tuple is smaller than the current tuple, then it's redundant. Yeah. So the other tuple here, so for instance, this tuple 00244 is smaller than the tuple that is the complement of it. So let me see this. So if I calculate the other, and if I make the tuples, so actually, how do I make tuples, to be honest? Can I make a tuple from a list? Can you do that? Oh yeah, okay, yeah. Just do a straight conversion. So if the tuple of the frequency is bigger than the tuple of the other frequencies, then I can say, I think redundant calculation detected. Okay, so Eeks. Not good, not good. Let's go ahead and why is this redundant one? This one should not be redundant this early, I don't think. Okay, maybe let's see. It's like this. It doesn't seem. That doesn't. That's definitely what I was thinking in my head. Unterminated string. Online. Oh, whoops! I deleted. Gosh. Huh. So, am I just confusing what the comparison operator is going to return? Maybe? Okay. Okay, but this is good. I mean, it just needs to be one or the other. Like one, I need just to use one or the other. So for instance, I'm pretty sure this is the breakpoint between when, this is like exactly break even. Anything after this, after this in terms of the value set is going to be complemented with something that is before up here. So like 0, 0, 2, 2, 3, 3 would be matching with the 0, 1, 1, 4, 4. So, and 0, 1, 1, 4, 4 was already calculated up here. 0, 1, 1, 4, 4. So I think here I can say that if I detect this, then I don't need to do anything. Okay, so that means maybe I can now just say return, I can just say answer plus equals count times other count. I think. It's actually count times other count times 2, because it could be ordered odd versus even, odd, or even times even versus odd. Except if it's the same exactly. If they're exactly the same, like 0, 1, 2, 3, 4, you can't really say that there's a duplicated way if you switch the ordering. So if the tuple of frequencies not equals the tuple of other frequencies, then answer is this. What am I doing? Answer is plus equals this. Else, if they're the same, then answer is equal to plus equals count times other count. Well, it's just if they're same, then they should be squared. Actually, I should probably just do that before this. So if I should probably do it right here. If tuple frequencies equals tuple of other frequencies, then answer plus equals square this count return. Okay. And then here, if they're not the same, then answer equals plus equals count times twice that much. Okay. Answer is not associated with the value. I think I need to make this self. I am not great at stuff right now. Boy. Oh boy. Actually, do I need to have self here? Oh my gosh. I really need to bone up on my instance variables usage in Python. How does this play out? Okay, I think it needs to be self.answer, make everything instance variables, and then I need to make this outside of this method. Oh, but then do I need to make everything else instance variables? Oh my god. Yeah, add count is not going to be defined in this case. Okay, where's this? Count is not defined. Oh my god. Wait, this is tabbed incorrectly. I want to do this. There was a way that I did this in other problems before. You have instance variables, and it's a lot easier when you're dealing with. Okay, I know what to do. This just needs to be a fucking return method, return function, rather than accessing the variables directly. The thing with Python that I'm not used to is the instance stuff. I'm a lot more familiar with Java, to be honest. Okay, so ignore all this self shit. Ignore the fact that answer is whatever. Return count squared. And here I'm going to return 0. Okay. And here when I call add count, this needs to be answer plus equals add count. Okay, line 100. Yeah, I really need to actually. Whoa. That's actually correct. Now that's kind of earlier than I expected. Okay, so it might be working for the even case right now. which is kind of what I was expecting in the best case, I guess. So let's go ahead and try a harder one, just a random one. So let's say 1933 6731. I don't even know if this works. That doesn't seem to work, right? This is even, odd, odd. Okay, let's see. Okay, cool. So it works for it works seemingly for even bags. Now for odd bags, or even versus an odd bag. Where would it fail in that case? Well, one way to try. Let's go ahead and just try the first case that they give us, 1, 2, 3. So somewhere here it's going to fail. Okay. So here, so simple case is the same. So next index, that should be fine. If the size times 2 equals n, okay, so this is it. It's never going to actually hit the end. I think if the size times 2 equals n or greater than n, then that should stop. Because one bag could be 2 and the other bag could be 1 out of 3. Okay, well, I was hoping it would be solved with that, but it didn't. Okay, so what's going on here? So special 1, 2, 1, 2 adds up to 3. So, oh yeah, okay, I see. I think it's because of this thing right here. Well, do I see? My answer here was 0. So it's definitely calling add count here, I think. Yeah, it's calling special. So add count. So what is it doing here? Oh, it's because of this thing. No, not doing a redundant calculation. I would print that. So this actually is calculating this. Okay, so let me just print out this thing. Added is that print added, and answer equals added. Can access local where is not associated with the value. Oh, whoops. X. Added equals the return value of that. Huh. So it's saying here that the number of ways, so if the number is 1, 2, 3, even bag should be, even the one bag should be 1, 2, the other bag should be 3. The number of ways that you do the 1, 2 bag should be 2. The number of ways that you do the bag that's 3 should be 1. So why? Oh, I think this should be size is equal to size should be equal to the length of the current indices, and then here the size should be equal to n minus size. Okay. Still not correct. Still not correct. So 12, that's unusual. And I also made the other stuff wrong. Excellent. Oops. Oh, whoops. I actually decremented size here. It should be size minus size equals n minus length of the indices. Length of the indices should be the current bag size. Okay, so I made the other thing rectifying. So this should be 2. Should be 4. This should be 2 ways of doing 1, 2. So that's 1, 2 or 2, 1. And then 1 way of doing 3. I think it's because of this thing. You can't actually, when you have an odd and even, you can't double it. So if it's odd even, then it's just count times other count. So if the length of if n is even, then you double it because the odd bag and even bags can be reversed. Otherwise, odd bag is odd bag, even bag is even bag. Okay, yeah. Okay, total frequency. Again. Yeah, do I need to get rid of some of this stuff before I try this out? Whatever. Alright, wrong answer. Redundant calculation detected. Oh, I still have the printout. 0, 1, 8. So the sum there is 9 plus 7, so 16. So should be able to do 0, 8, and 1, 4, 3. 0, 8, 1, 4, 3. And I had an answer of 0. So there should be, if you do 0, 1, 4, 3, then that's basically 3 factorial. So that should be 6. And then 0, 8 versus 8, 0, that should be 2. So yeah, 6 times 2 is 12. Interesting. Wonder where this thing failed. Okay, let's go ahead and just print out some stuff then. I don't think I need that. Alright, so the bag is 134. Oh boy. I see. This is the comparison of the tuple versus the other tuple. That really doesn't apply when it's odd. Yeah, I was thinking this might be an issue before, even though I didn't fix it. So if it's odd, no, so this, no, if it's even, then it's a redundant calculation. If it's odd, then it cannot be a redundant calculation. Okay, yeah. So let's see if that fixed up the thing. Okay. More incorrect cases. Alright, so I think I probably want to actually print out the digits so I know what the indices are representing. So print out this and print out the digits. Whoops, I'm going to print this out after it's sorted. Alright, so the digits are these. The sum of this, oh my god, what is the sum of all this shit? Print out the digits, print out the sum. Alright, so the sum is 88, so the necessary thing is 44. Looks there, there's 1, 2, 3, 3, 6, 9, 12, 12 plus 5, 17. So that's an odd one. Okay. Does it ever hit 44? What was my answer? My answer is something. Oh, I don't think I ever used mod. Answer plus equals. Answer added. Answer equals. Answer plus added mod. Okay, it's just mod stuff. Okay. Too slow? Might be too slow. There's a couple of optimizations that I've been thinking about I need to do. Yeah, okay. So it can go up to 80 long, and that means that a lot of the short strings that I'm testing on could be much longer, which requires much more computation. I'm basically doing every single possible thing, every single possible combination. But there are ways of quickly determining whether or not like a certain path is eventually capable. So the optimization I was thinking of is there's going to be a maximum increase that you can have at any given point, and if the remaining elements, the maximum that you can add to the current set is not going to reach the halfway mark, then you need to immediately stop the current set and just jump to the next number. So rather than wait until the very end to determine, like, you know, you're adding a bunch of zeros or ones and you've reached the halfway mark of the number of elements that would be required and you're well short of the goal, rather than wait until like that point. If ever you detect that if you filled out the remaining elements of your bag with the maximum possible elements right now, that it doesn't even reach halfway, then you just need to stop the current bag. So the way to do that would be I'm going to have a max remain array, and after I sort my current digits, the max remain is going to be of size, let's say this is 0 times n divided by 2, n divided by 2 plus 1, n plus 1 divided by 2. I want to be equal to the first bag that I actually do. So I think it's maybe n plus 1 divided by 2. Because even if I do the odd bags will, like if it's a 3 and a 2 bag, it'll check for the 3 bag versus the 2 bag. So I think it should be n plus 1 divided by 2. Okay, and then for k in range k in range of, I think that number, n plus 1 divided by 2, if let's say I have let's say I have r sum is starting with 0. I say r sum plus equals the maximum digits at negative k minus 1. So that's the first digit, the largest digit that's in all the digits. And then I'll say max remain of negative k minus 1 is equal to the r sum. Okay, I think this is what I want. I'll go and print out max remain. Hopefully it doesn't go out of bounds. It goes out of bounds probably. Max remain equals, oh yeah, put parentheses around this thing. Okay, so the case that I was thinking of this is this thing right here. So if the numbers are 0, 0, 1, 1, 2, 2, 3, 0, 0, 1, 1, 2, 2, 3, 3, 4, 4, then the max remain of if you only have one more element, then the biggest thing that you can have is a 4. And then if you have 2 more elements, the biggest thing that the max remaining that you can get is 8. If you have 3 more elements, then the max remaining would be 11. And then if you have 4 more elements, the max remaining you can get be 14. And then 5 more elements, and the max remaining would be 16. So that's exactly what print out 16, 14, 11, 8, 4. And then if the current sum plus the max remaining doesn't equal the halfway mark, then you stop. So I think I think you can put it right here maybe. Yeah, I think here. If the current total plus the max remain from this size is less than half, then add index should equal negative 1. So ignore whatever you were going to put down there anyways, and just stop. Like, just remove the current element and try the next element. I think this might work. This might be a little still buggy though. Okay, so what's going on here? Size. Okay. Size could be actually the size of the thing. Could be out of bounds. How is it out of bounds actually? Size is currently what? What is it doing now? So size is currently 2. And my max remain is 5.3. Do I need to just append a 0 to it? Maybe this works if I just append a 0 to the max remain. Or I can do max remain of n plus 1 divided by 2 plus 1. No, that definitely does not work. That's gonna click that. I need to append a 0 at the very end of this thing. Just because of the way I coded this this portion. Okay, so that stopped it from going out of bounds, and it still logically works. Alright, this is one of the 2 optimizations. Let's see if it works in terms of getting it there. There's another optimization I can do in terms of the same kind of deal for being too much rather than too short. But let's see how good this thing is. Okay. Looks like it's still timing out. Shucks. Oh man, and this is the same thing as well. Is it the same? Maybe it isn't. 7.2. I thought I inserted the test case. Yeah, it's the same deal. Okay. Okay, so the other thing that I could do is if it goes too big, then it needs to stop as well. So if the total plus max remain is bigger than less in size, or the total is already bigger than half, then add index is -1. Okay, maybe, I don't know. I should have done the test run on that time limit exceeded. Still doesn't seem good enough. Doesn't seem good enough. Well, that's a different 638. No, it's the same. Time limit exceeded. Okay. Does this work if I just did it by itself? Okay, so it works just going by itself, but with all the other stuff, it's not fast enough. Yeah, so this is almost a full second just for this test case. And this case is not even that long. Let me go ahead and just print it. Print out my number of digits, please. I guess that's just n, right? This is probably something like 20, maybe? Okay, that's 43. So it's like halfway there. That doesn't look like it's 43 letters. So what other optimizations are there here? So there's the calculation optimization, possibly. Worry is that it has to do with my actual algorithm. Like there's a better algorithm out there that doesn't use the backtracking deal that I've used. And if that's the case, then I'm going to be really screwed. I can maybe do some other optimizations that don't like totally rewrite all this. So if it's a calculation optimization, I don't know if it's calculation optimization. It could be. What could it be? All right, let's go ahead and take a peek at a hint. Count the frequency of each character in a string. Okay, hint 1 has already been done. Oh my lord! Oh my god! Dynamic programming, not backtracking? Oh no! Alright, the question is whether or not I could also still use backtracking versus dynamic programming. No. Generally, man, if I'd seen this hint earlier. Generally, dynamic programming is like n squared, and backtracking is like maybe n factorial. Boy. That's a different order of magnitude, so that means I can't use backtracking. Oh my god. All that. All that. Fuck me. Well, I mean, it was good practice, I guess. Good practice, I guess. On backtracking. Iterative approach. How to fail. Okay. How to fail indeed. How would I do dynamic programming? So you have your indices. Have your indices in your sorted digits, and for each index. So whenever I do dynamic program, I'm always thinking of like a 2D array. So in this case, what is the 2D array? So your indices, so let's say the digits are 0, 0, 1, 1, 2, 2, 3, 3, 4, 4. So 0, 0, 1, 1, 2, 2. And technically those are the indices that map to that, right? Again, these are the values. These are the indices. So my other dimension is whether or not I have that in my bag. Whether I have that in my bag. The number of ways you can get up to that index with half the number of ways you can get up to that index. What is my other dimension? So for each index, you either can include that or not include that. For each index, you either include it or not include it. Some of these indices have the same values. So even if you include 0, I mean, it's kind of dependent. It's not like if you include 0 in the first try, if there's 2 zeros and you include the first 0 and don't include the second 0, that's the same thing as if you include the first, if you don't include the first 0 and include the second 0. So I'm not sure, I'm really not sure how that would map out. So we have dynamic programming. So dynamic programming, there's some like iterative relationship between one case and the next case, between the solution for n minus 1 versus the solution for n. So what is that? What is that relationship? Number of ways you can get a certain total using the first k. So let's say the sum is s and h is the half sum. So the ways you can get and let's say this is function of some array up to some length n. Is like the function the total number of ways is the function for the array n minus 1 where you're trying to get h minus array at n kinda plus f of array at all the way up to all the way up to n minus 1 h. So if you have a certain sum that you're trying to get, or a certain half sum that you're trying to get, you can get the total number of ways of getting that half sum in everything except for the last element. So for instance, if you're trying to get the half sum, the sum is 20 and the half sum is 10, right? And the last element's 4. So the number of ways you can get like 10, not including the last number. So 10 not including the last number. Or 6 not including the last number. Because if you have 6 not including the last number, then you can get 10 using the last number. Or if you have 10 not using the last number, then you don't have to use the last number. And that does kind of map out. The only issue here is like it doesn't count redundancies. Like there could be the same number. It could be the same number multiple times. So they're identical 4s if there's more than one 4. There's identical 4s if there's more than one 4. Yeah. Okay. Okay. Even though my method is slower and works, just have to rebuild. So how to recalculate length? Yeah, let's go with a smaller number. Too small. Maybe. What about that one that gave me 12? Okay, this one. So 14308 is the solution. 143 versus 8. So sorted. 1, 3, 4, 8. The sum is 16. No. Yeah, 16. The half sum is 8. How do I get 12? How do I get 12 using dynamic program? So it's the number of ways. So if I think about maybe reducing the problem, if I ignore the 8, I know that 8 is equal to the half as already. So if I ignore the 8, then it's the number of ways of getting an array that is 0, 3, 4 where the goal is 8 or 0. Okay, so if I take away 8 from here, then I get 0. If I don't take away the 8, then it's still 8. So the goal is 8 or 0. And then susceptible to that would be the number of ways. So if 4 is my last number, then it could be the number of ways I get to 4 or 8. I can't take away this 4 from 0. So there's 0 ways of getting 8 from these numbers, but there should be one way of getting 4 is 1, 3. And then susceptible there is the number of ways I get 4 or 8 or 1. So if I subtract 3, and then this is going to be, well, I guess this is always going to still just, the 0 just stays, right? Yes, the 0 just stays. So this ends up being 1. This ends up being 2. So this is 2. Well, this returns 1. This returns 2. This ends up returning 2, I think. No. This should end up returning I think this ends up returning 2 times, and this should end up returning 3. Like 0 is 1, and then 1, 3, or 3, 1 is 2, so it should end up being 3. And then this should end up being Eeks. What does this end up being? Okay. This should end up being somehow it needs to get to 12. So returning 0 from 0 is just 1. Returning one of these things from 0, 1. So is that 2? 1 plus 1? It's 1 plus 1. And then returning 0 is 1. And returning 4, there's 2. So I think that could be 1 plus 1, or that could be 1 times 2. 1 plus 2. So here the goal is 8 or 0. Well, the 4 is, I want to say the 4 makes it 6. 6 plus 1. I think I feel like there's somehow something I'm missing here. I think it's 6 times 1 at this point. And this is like 6 times 2 at this point. And I think this is actually like 1 times 2 at this point. Yeah, I think that's, well, 1 times 2, 2 times 1. And this is actually just 1, or this is 1 times 1. Why do I think that? It's because it's like the number of ways of forming one bag versus the number of ways of forming the other bag, and then the total number of ways it's forming is the product of those two. So the number of ways of forming the 8 bag is 0, 8, or 8, 0. And the number of ways of forming the 1, 3, 4 bag is 6. So this should be 6 times 2, and this should be 6 times 1. So if the goal is 8, yeah, if the goal is 8 or 0, there's one way of forming the 0, 6 ways of forming the 8. And then here, the goal is 4, 8, or 0. 0 ways of forming the 8, 1 way of forming the 0, and 2 ways of forming the 4. And then here, it's 1 way of forming the 0, 1 way of forming the 1, 1 way of forming the 1. Interesting, interesting. I think this is pretty close to being, I mean, logically it makes sense in my convoluted mind. Okay. How do I deal with redundancy? How do I deal with redundancy? So redundancy being something like 112. 112. I don't think I really want this, but I'll keep it anyways. Okay, there's really one way of doing that. Okay. So sum is 4. Half sum is 2. So the sub goal is going to be 1, 1 is my array, and the goal here is going to be subtracting 2, so it's going to be 2 or 0. Okay. And then that's going to make it a sub goal of, if I remove one class element, the goal is going to be 1, 0, -1. Right, obviously there's only one way of doing this. And then there's one way of getting the 2. Is there one way of getting 0? 0 ways of getting 0? Yeah, I think there's 0 way of getting 0. I think. And then this is going to be what exactly? 1 times 1. So there's one way of getting this 2 and one way of getting this 2. So 1 times 1. Oh, mama. And the length have to be the same too. Oh shit. Length has to be accounted for. Fuck. I did not remember that. How do you account for length? I mean, could you possibly... I wonder if that's where the dynamic program comes in. So, dynamic programming coming in where at any given point k is the number of elements that you've used. Yeah, so if you have all your indices, k is the number of indices that you've used. The redundant part, the redundant values is what goes to it. Okay, but so if you have 10 values, then you can only use 5 of those values for one bag. So you could count the then for each way that you're calculating the bag, you need to actually calculate the other bag as well, right? I guess if it's an odd number, then it doesn't matter. Well, no, it does matter. So whenever you add to the count on k, whenever you add to the count on k, do you also add it to the bags? And bags kept track of as well. Oh. Oh. Alright, let's try this again. So 1 0 1 2 0 1 3 4. So here again we have so E is the number of elements. So there's going to be at most 3 elements that you use. You have to use 3 elements exactly. Okay, so you need to get to 8 using 3 elements. So the sub goal would be if you had the array excluding last, where your goal is 8 and you still have 3 elements, or your goal is 0 your sub goal is 0 and you have 2 elements. So because your bags are going to be 3 and 2, so the number of elements is either 3 or 2. Then if you remove the last element, then your sub goal is either 8, not using the 8 and your nums, and with E3 or 2, or if you did use the 8 and your thing is 0 at this point with the number of elements remaining as 1 or 2 or 1. Okay. And then that breaks down to 0, 1, 3. So if you use the 4, or let's say you don't use the 4, so you still have goal 8 with elements. You still have 3 or 2 elements that you can use. Or if you did use the 8, if you did use the 4 out of the 8, then sub goal is 4 with elements 2 or 1, or if you didn't use the 4, H of 0 with elements 2 or 1. Whew. And now from 0, 1. So if you do use the 3, or let's say you don't use the 3. So if you don't use the 3, then it's the same stuff as before. Yeah, if you don't use the 3, then it's the exact same stuff as before. If you do use the 3, then it's 3 less than the stuff before. So H is 5 with elements 2 or 1. Or H is 1 with elements 1 or 0. Or well, you can't remove the 3 from this. Oh my lord. And so you get to 0. And I think, well, the only thing that would work at that point is this thing. So that returns 0. Or that returns one way of doing that. And then, so this is what is this saying? So there's one way of doing the 0, and then so this is recursion right here. No, is this recursion right there? Like, there's one way of doing this, and there's one way of doing this. So it's like 1 times 1, maybe, something like that. And then here, so this thing right here, there should be 2 ways of doing this, 0 ways of doing this, 1 way of doing this. So that's where it becomes 1 times 2. And then here, there's 1 way of doing this, and 6 ways of doing this. Okay, well, I don't know if that made any difference. I logically came to the same conclusion through the maybe logic of incorrect faulty logic. There's 6 ways. So where am I leveraging my dynamic programming aspect? Where am I leveraging it? So you have your 2D matrix. You have your 2D matrix. What is the relationship between elements in the matrix? What is the matrix? So you have 0, 1, 2, 3, 4. 0, 0, 1, 0, 1, 3, 8. And this is like the number of elements that you've used. It's the number of elements that you used. So what the halfway mark is different for halfway mark is different for each. Thanks, Al. So it's not like, unless you have a 3D matrix. Oh god, that sounds horrible. Like one dimension for the value, one dimension for the number of elements, one dimension for the sum that you're trying for. Man. If I do a 3D matrix, that'd be 80 times 40 times sum, where the sum can be at most 800. 80 times 40 times 800. So it's not 2 million. I guess it's not impossible to do with the matrix here. Oh my lord. Yeah, maybe I can do a 3D matrix. So the relationship between the number of ways you can get to each box so so you have 16, 8. So yeah, the number of ways you can get 8 using 3 elements times we add Need another visualization here. So 0, 1, 2, 3. I'm gonna go with sum. So sum 0, 2, 3, 4, 5, 6. The sum has to be 8. And the sum has to be 8. And you have to use 2 or 3 elements to get to 8. So let's say this is the E equals 3 layer. And so this is one slice of a 3D matrix. Oh. Second slice, third slice, fourth slice. Okay. So what's going on? So if the goal is 8, so like, so I think what's gonna, so it's odd. So whatever is in like this box, getting 8 with 3 elements and getting 8 with 2 elements by the last index. Let's say this is A and B. Those two values would multiply to get 8, to get the 2 bags. Okay. Okay, so if you want to get 8 using 3 elements, you want to get 8 using 3 elements, then that boils down to either you get 8 using 3 elements, not including this, not including the last number, so it's 8 using 2 elements from 0, 1, 2, 3, or 0, 1, 3, 4, 8 using 3 elements. Yeah, okay, so let's say B is 8, H half sum is 8 using the 3, I'm not sure why this B, so using 3 elements from 0, 1, 3, 4, 8, and 8 is getting sum of 8 using 2 elements, 0, 1, 3, 4, 8. And then this one breaks down into, you can either not use the last element or use the last element. So if you don't use the last element, then the sum is still 8. You have still 3 numbers. Now your array is 0, 1, 3, 4. If you do use the last element, then the sum is 0. You have 2 elements that you need to use out of that. Okay, I'm going to label these. Let's say this is C and this is D. So sum of 8, 3 elements, 1, 3, 4, C. Sum of 8, 3 elements. Sum of 8, 3 elements, 1, 3, 4, C. So I think this is C. Okay. Sum of 0 from 2 elements out of 0, 1, 3, 4, and that's D. Sum of 0, 2 elements. Sum of 0, 2 elements, 1, 3, 4, that's D. And then I can break this down into, you can either use the 4, where if you use the 4, you get sum of 4, 2 elements out of 1, 3, 4. And if you don't use the 4, then the sum of 8 is still there, 3 elements out of 0, 1, 3. And let's say this is F and this is G. I'll stop pretty soon here. So sum of 4, 2 elements. Sum of 4, 2 elements. So this is F. And then sum of 8, 3 elements. Okay. So what is this saying to me? I mean, so yeah, there is a 3D mapping for this. And then what? So eventually 3D mapping goes down to 0 elements and or 1 element. And that 1 element either works or doesn't work. If it works, then there's one way of doing that. If it doesn't work, then there's 0 ways of doing that. And then it percolates backwards up, backwards. I have to fill out the whole matrix. Okay. I have to fill out the whole matrix. Probably from the E equals 0 all the way up. Fill out the whole matrix. Question is, when I fill out the whole matrix, how do I incorporate the counts? When I fill out the whole matrix, how do I incorporate the counts? So if the sum is 0 and the number of elements is 1, so I think I go something like, I go for E equals, so the bottommost layer. So I have 0 elements, and I have any number of these. This should all be 1, I'm pretty sure. There's one way of doing No, there's one way of doing zeros, and there's 0 ways of doing everything else. Like, that pretty much logically has to work. Right. Yada yada yada. Okay, because if your 0 elements, then your sum is obviously 0, and you can have one way of not having any elements up to any point. Is that right? Is that right? So, yeah, if you have 0 elements, then you have 0 elements. Just one way of doing that. Okay. So, that layers set. And now you have the first layer. So, if you have one element, then the number of ways you get the sum of 0, given that you have 0 value, then I think that's just 1. Like you include 0 in your array. And all these other ones are 0. Because you cannot sum up to any of these other numbers just based on having a 0. Then if you have a sum of 0, what is this going to be? I'm pretty sure this should be 1 right here. Pretty sure that should be 1. So there should be one way of having one element where that one element's 1. Is there, how many ways is this thing right here? I think this should be 1 right here, I feel like. So I think it should be considering up to this point in the array. So up to the point where the array is 0, 1, how many ways can you have a subset that includes 1 element where the sum is 0? And there's 1 way. And all these other things are 0. Even bigger than all this stuff is 0. And then here, up to this point, again, the sum of the number of ways you have a bag that has 0 would be just 1, where the bag has the element 0. And then the number of ways to get 1 is 1, where the bag is 1. And the number of ways to get 2 is certainly 0. 3 is 1. Yeah, your bag is 1. Is the single 3. 4. Ooh. If your single element is 4, so that should be 1. Single element 5 should be 0s. Single element 6 should be 0s. Single element 7 should be 0s. Single element 8 should be 0 up to when you see the 8. Alright, so here there are two elements. Two elements when one of the bag is 0. Two elements when one of the bags is 0. Then what is this going to do? All zeros here. Sum is 0. Is it one bag has 2? I think this should be 0. Man, how would you even have how would you even have two elements when there's only one element in the array currently? I think that should be 0. Maybe it should be 1. In any case, I think this should be I mean, it needs to end up being that at 8 there's 2 ways here, and at 8 there's 3 ways here. No, 6 ways here. Those need to end up being the answers in those spots, because you need to multiply those out. 6 times 2. Otherwise well, in my current logic anyways, otherwise it's not going to work in my current logic. No, that should be 6. So those should be the upper bounds of the answers in this layer. So zeros, I think this should all be 0. So it needs to actually grab 2 things, and the sum of those 2 things is exactly 8 for this formula. So that means it needs to grab exactly 2 things with exactly those things and add up to 1. So in theory, 1 and 0 could add up to 1. So here it's 0, this is 1, this is 1. I guess I was about to make a generalization about the relationship between the neighboring cells, but I guess it doesn't follow. Okay. I guess maybe if there's if you're on the same level, then it needs to strictly be increasing, or on the same row of a level. It needs to be strictly increasing, it can't be decreasing at all. This is kind of weird here. I might imagine this should be a 1. So, but no, it definitely is not 1. Yeah. Yeah. So grabbing sum of 2, grabbing 2 should all be zeros. Sum of 3, grabbing 2 should all be zeros. Sum of 4, grabbing 2. Actually, sum of 1, grabbing 2. I wonder if this should be 2. Because it could be 1, 0 or 2, 1. or 1001. And then sum of 4. Sum of 3. Actually, this should be 2 here. And then sum of 4 grabbing 2 here. 5. Technically, it could be 2 here. 6. That's all zeros. 7. It's all zeros to here. 8. That's 0 up to the 2. Okay. So I think, so if you have a certain level here, it's this level is related to this level. Right. Like if you were to actually slice the layers on top of each other, there is a relationship between the levels somehow. Oh boy. And then this layer needs to be something like 0, 0, 0. Well, no. Yeah, 0, 0, 0. Yeah, this will all be zeros here. And zeros here. The lowest sum should be 4. Should be 6 right here. 0. No, this should be 6's, right? And then this should be 0, 1, 4. 6 ways. Zeros. Zeros. Up to the 3, 4, 0, 3, 4. And then this should be 6 at the point. Okay. Okay, well, I built the whole chart in the way that I think it should work. Up to that point in the array, how many ways to get to that sum using that number of elements? I wonder, is there a way to calculate that with repeated values? Like if there's another 4, these are all unique values, but if there's another 4, I think maybe you can, maybe you divide out the number, maybe you divide out the previous number by the number of repeats. Oh. Okay, okay. Let's see if I can't generate something like this. Okay, so close. Well, c'est la vie. I think I just need I think I need to just bomb all this. Yeah. I think I just need to bomb everything. Just move it down here, just in case I need to refer to some stuff. Alright, answer 0. Let's go ahead and do digits is integer of k for k and num. Digits that sort on. Let's go ahead and print out the digits. And let's go ahead and do total frequency. Totals is equal to the counter of my digits. Say S is equal to sum of the digits. H is equal to half the sum. And to the trivial case, trivial non-working case. If S is odd, turn 0. You can probably do that first. And let's do n is equal to length of the number of digits, or length of string. Okay, probably should calculate S before, or make digits before doing that. Okay, back to square 0. Square 0. Okay. So my DP matrix is going to be it's going to be 3D matrix. I think it should be S plus 1 divided by 2. Round it up. It's going to be 0 times 0 times n plus 1, and that's going to be an array for k in range of h, and that's going to be another array number of, oh my god, yeah, that's disgusting. For, let me say, for h in range capital H, for for the number of elements, which is going to be up to the length, half the length of n. Oh my god. The number of elements. I actually need to worry about the order of operations here. So what do I want as my outermost loop? The outermost loop is probably the number of elements, right? That's why I'm mapping this up based on number of elements. So number of elements, which is for E in range. For E in range, n plus 1 divided by 2, n divided by 2, n plus 1 divided by 2. Well, this is going to be way too big to print out for some of the test cases. I probably need to pause on this test case right here. Not any of these big ones, too big to print out. Too big, too big, too big. Yeah, you're stretching it, buddy. You are definitely stretching it. Okay. Syntax. 1, 2, 3, 1. That closes that thing, that closes that thing. Okay, so what is this? And this is correct. So 1, 2, 3. So indices are 0 to 3 plus an extra one, 4 is fine. And then the half sum is going to be up to 3, which is fine. So seems a little short. Seems like it's 2. I'm expecting it to be 3. Let's go ahead and print out some shit. Print out n plus 1 h and n plus 1 divided by 2. Four, 3, 2. Oh. Yeah. This is 3, then I should do it 3 times. But what is it doing 3 times? Oh, okay, yeah, okay, so 1, yeah, so it's 3 arrays. There's some extra bracketing in these arrays that I don't think is necessary. Or not even necessary, that's not correct. Maybe it's removing there. I think maybe it should be like this. This is an array, 2D array. Extra. So it's 4 here. Zero times 4, so that gives you that. Or h in range. Okay, I think maybe I am missing parts for now. Okay, there we go. So Okay. I think I do want the case that was, case is gonna be extremely long, no? Might be extremely long, but might be useful. 0, 1, 3, 4, 8. I'll add it. 0, 1, 3, 4, 8. Okay. Is this what I expected? Maybe. Maybe. So I did 5 wide, but it should really be 6 wide, maybe. So it's that thing. So let's say E in range. I should make this a variable. Fn is equal to n plus 1 divided by 2. Automatically space. I think it automatically spaces. Okay. 0, 1, 2, 3, 4, 5, 6, 7. I think I need 8. So I think this should be for h in range from 0 to h, inclusive of the half sum. So the sum divided by 2 plus 1 is not rounded up. It's actually just plus 1. No, the half sum is the half sum, but this should be h plus 1. Yeah. Okay, sum is 0, 1, 2, 3, 4, 5, 6, 7, 8. Okay. Yeah, I think this is, D should be 0, 1, 2, or 3. So, E, N is 5. Okay, so it's half N plus 1. Yeah. All plus 1. Okay. It is 0, 1, 2, 3. Yeah. 0, 1, 2. Okay. All right. So now to build the matrix. Now, the question is how to build matrix. Let's go connect this stuff up. So building the matrix for every element for e in range fn plus 1. So starting with 0 elements and going upwards. So actually, I think on the bottommost layer, I need to start with 1s here somehow. On the bottommost layer, you should have one way of getting zeros for everything. One way of getting zeros for everything. So I think it should be for every index. So for every index in n plus 1 dp matrix. Okay, so dp matrix, just for reference here, this 3D matrix of 2 storing the number of 3D matrix with dimensions of 1 every index slash value. In array to every sum up to that index, every number of elements in bag get. And this is going to be dp matrix elements sum and index. So the number of elements is 0, the sum is 0, the index is this variable is equal to 1. And then oh, indentation? What do you mean? What do you mean? Did I indent something? Oh. Okay. Right. This is what I want. There's one way of getting the sum of 0. The sum of 0 using 0 elements. Guaranteed. Okay. And this is initialize to have one way getting sum of 0 for 0. Okay, so now what is this going to be? So for every this needs to be just comment out. For every number of elements that I can include. and then for every sum, so what variable am I using here? Bag sum in range. What is this? H plus 1. And then for every index in the range of n plus 1. Okay, and now just to fill it out, dp matrix of this number of elements, this bag sum, and this index is equal to what? Some relationship between elements in the matrix. I think it's equal to, it's like, you need to look at the current element at this spot, the current value at this spot. So let's say the value at this spot is digits at this index. And okay, so it's something like dp matrix of this number of elements, this bag sum. If you have the same number of elements, then you have the same bag sum, but with one less index. And then maybe combined with one less element, the bag sum includes this value. So bag sum minus the value, index minus 1, something like that. This can be negative though, bag sum minus value. So let me break it down into two parts. So part 1 is this thing. And then part 2 I initialize to 0, and then I say if the bag sum is smaller, is bigger than, or equals to the value. And part 2 is this. Something like that. Something close and something far away from that. That covers all the bases. So I have some number of elements, part 1. No, this cannot be right. What the hell am I doing here? I think it should be index minus 1. It should always be index minus 1 because you always should be looking backwards for the parts. And then there should be a part 3. There should be a part 3 maybe. There should be a part where it calculates it based on, or does some sort of calculation. Well, it has to be some sort of calculation, but where it looks at the duplication possibility. and it should be maybe multiplying these two parts. Is that correct? I don't think I multiply here actually. I think I need to fill out this whole matrix and then just do the final calculation based on the whole matrix at the very end. It's not really, I don't really do the multiplication here, I don't think. I could be wrong. Could be wrong. Maybe I should, no, maybe I do need to do the multiplication here. Yeah, there's probably some multiplication here. Okay, so what I really want is for this thing to show up like this matrix that I came up with here. But is this going to work? And what do I do with these two parts? So I multiply them? There's something off here. Like this is never gonna, it's never actually gonna reach 2 or 3 or 6. So if you're inserting a new element and there is a previous element, okay, so if this is the number of ways that you get to, so this is including the current elements basically, right? So part 2, you're using the last element, so that's why e is being subtracted by 1 and the sum is being subtracted by the value currently. So however many ways of doing that, you can insert the current value in, you need to multiply that by that plus 1, I think. So if there's like 2 ways of not including the, so for instance, if you're dealing with 0, 1, 3, 4, adding up to 8, and you say that you're looking at 1, 3 and adding up to 4, there's 2 ways of doing that, 1, 3, 3, and 1. So you have to multiply that by plus 1. Part 2 is equal to part 2 times equals part 2 plus 1. I guess I don't need parentheses there. Yeah, and then you insert 4 into the 2 ways of doing 1, 3. There's 6 ways of doing 1 through 4. Okay. And do I multiply these 2 ways? Multiply ways of doing part 1. But there's 0 ways of doing part 1 and some number of ways of doing part 2, then I don't want to multiply 0 times 6. So the number of ways that you can get this thing number of ways you can get part 1. So you have the same number of elements, the same sum, but using the previous amount of array. So this thing is 1, and this thing is 1. Because this thing's 1, this thing has to be 1 here. So the index minus 1 for the same elements number and the same backsum, that's part 1. So 1 here has to equal that. Is it just the maximum of those 2? The number of ways the maximum of 2? So where did it change? Does it ever change in a given row? This should be 2. What am I doing here? This is 2. So the number ways here. So this 6, where does it come from? So 6 came from the number ways of getting 3 out of 0 and 1, which should have been 2. No, it should be 2. It should be 2 right here, I think. Because you can add 1 and 3. So this, there's 2 ways to get, wait, what am I doing here? No, that's incorrect, what the fuck? 0, 1 sums to 2. No, 0, 1 sums to 1, 1. And 0, 3 sums to 3. So this number 2 which is that number. 1 less element, the bag sum of 6 minus 3. So the sum of index minus 1. So that's 2. And that made it to this number, which is 6. And that 2 came from like that 2. Another way to get 3 came from this 1. Number of ways, no, it came from this one. Okay, fuck it. I'll say dp matrix a bag sum index equals the max. Alright, let's see what this gives me. Probably not correct. Almost certainly not correct. Values digits that index. Yeah, so why is this going to n plus 1? I think I'm messing up here. Should be n values that, and then this should all just be this index, and then this should be index plus 1. Okay, so what do I have here? Ooh, what do we have here? Uh, 42 seems a bit generous, bit optimistic, but I wish I made these things opposite. Can I just switch this? Okay, so 2, 2, 2, 2. I think that's that. So that's 0. 0. Something And the others. Hmm. This should be 1. Should not be 2. Okay. I mean, I feel like this thing needs to be like this initially, otherwise it's going to be just a fat 0. Yeah, I'm pretty sure if I just made this thing all 0, this is all zeros, almost guaranteed. Yeah, it needs to be. I'm pretty sure this is correct that it says 1 right there, but I am screwing something up pretty badly. So if the number itself matches the current bag sum, then I just need to set to 1. I can't do the multiplication of 1 times 2. I am almost certain, because if you is that right? I feel like that's right. So if the value itself equals the bag sum, then it's a 1. That did not fix it. Yeeks! Oh, sorry, this should be continue. We should just break it, pretty much. Okay. That's what I was envisioning, kinda, maybe. So E0 matches. E1 pretty much matches. I mean, there's offset by 1, whatever, but pretty much matches. This is bad. God, this looks so. Can I just print this out backwards somehow? I guess I can't. Maybe if I do E reversed, print dp matrix of E in reverse. Like, is that right? Object is not printable. dp matrix of E in reverse. I don't think that's right. Or maybe it is. Yeah. Okay. So you don't like me modifying the layout. Okay, that's fine. So E0, bottom row is 1s. E1, bottom row is 1s. Then you have another row of 1s. Then you have row 0s, 1s, 1, 1 on top. E2, bottom row is 0s. Then you have 2s, 0s, 2s, 2s. There's an extra 2 here. Zero, 4 twos, 3 twos, 3 twos. Should there be a 2 here? Yeah, there should be a 2. It's 1, 3 versus oh. I wonder, should this be 4 actually? How many ways can you make a grouping of 2 elements with whose sum is 4 up to this point? This should be 4, really. Right, this should be 4 here and 4 here, because you can do 0, 1, or 0, 4, 4, 0, 1, 3, 3, 4. Oh my god, 0, 4, 4, 0, 1, 3, 3, 1. So there should be 4 ways there. 5 here is just 4, 1, 4, 4. So I'm screwing that up, and it's not affecting the, well, it's not being calculated. It should be calculated. It's not being calculated. It should be calculated. I don't think it probably doesn't affect the result, but it could. It's getting 6 on top here. Oh yeah, because it could be 1, 3, 4. Yeah, this is, I mean, this is almost certainly wrong. This should be 12 right there, actually. Yeah, it's matching what I'm currently have, but my current calculations is definitely off. But this should definitely, this is almost certainly, actually, maybe this is just, because the number of elements should be 6. So you need to grab 3 elements. So it needs to be 1, 3, 4, 1, 3, 4, some combination. Some permutation. 1, 3, 4, 3, 4, 1. Okay. So is it supposed to be multiplying? So the number of ways that you can grab it without taking the current elements times number of ways. What if one of the ways is 0? It's definitely not adding, right? Is it definitely not adding? Could it be adding? Up to this point in the array, how many ways can you grab that number of elements and have that sum? So up to the point in the array, 1 less, where you don't have that element. And now you do have that element. So that's part 2. And so they're disjoint, I think. Yeah, they're disjoint unless the value itself is 0. In which case it's overlapping, I think. In which case I'm kind of screwed. Maybe this should be part 1 times, but then if part 1 is 0, then it should just be part 2. How many ways? Maybe it could be initializing to 1 instead of initializing to 0. Or the calculation starts by multiplying by 1. So the part, if it's not 0, then it multiplies by 1. Put 1 not equal to 0, input 2. This seems like a very bad hack. Like I'm not convinced of the logic. Not all convinced by logic of that. Well, it did get this to 4, like I was thinking. Should be the case. And then the other stuff stayed the same. Okay. Return. So what am I thinking about here? What should this be returning? This is definitely just all sorts of wrong, I think. This is all sorts of wrong. So if it's the odd case, if n mod 2 equals 1 is odd, then you return the DP matrix of this number of the number of elements, that is half n. Half n is going to be, is that going to be 1 short? Yeah, it's going to be 1 short of sum, which is h. This is going to be h plus 1. I want to say h plus 4. I want to say h. H is the sum times dp matrix of half n plus 1, h, and it's the last element. So up to the last element of the array. And then otherwise return 0. Out of range, okay. I think this is probably out of range here, half n plus 1. I think there should be maybe -1 and -2. -1 and -2. Okay. Well. That's trivial case. It's not trivial, but this case is just off. Okay. This is duplicate case. Yeah, I did not solve the duplicate case. Okay, so what should this be? 1, 1, 2. 1, 1, 2. So for the 0 elements, sum is 0. Just want to redo that. For 1 element, sum is 0. There's 0 ways. Sum is 1 up to the first element. It's going to be 1 way. one way, one way. Yeah. Sum is, so the number of ways where you have two elements, and the sum is 2. This should be 1. Because 1, 1 is not different than 1, 1, which I am currently thinking of, which is current calculation. 1, 1 is different than 1, 1, but 1, 1 is actually the same as 1, 1. So here. So what's the calculation going to be? So if you have another duplicate 1 on top of 1, or if you have a repeated value that you're adding, then the number of ways. Okay, so let's go ahead and just do a small test case here. Okay, so let's say your numbers are 0. Let's say your number is 1, 2, 2, 2. So let's say you have 1, 2. So the sum is 3, and you're adding another 2, and you're trying to find the number of ways to get 5. And you calculate it to be 6, but it's actually 6. It's actually 6 divided by the number of times that you repeated. Is that right? So currently you're saying, currently you have some number of ways, and you're multiplying it by the length of the string plus 1. Because you're assuming that, like, if the length of if the string is currently 2, then you're assuming that you can insert it into like 3 different spots. Maybe I should use a different character. Inserting into 3 different spots between where the current values are. But no, actually, if you have a duplicate value, putting it here, here's the same. So assuming that it's an accurate number for the number of ways previously, and there's some number of duplication of the currently added value. So previously there's 2, right? It's 1, 2, 2, 1. And if you add another 2, then instead of becoming 6, it should just become 3. So it's actually 2 times 3 divided by the number of duplications. The number of duplications, which is 2. I think that makes, well, yeah. Okay, so the number of times the current value is duplicated within the string. Within the string, that's the string up to here. Current number times the value has been duplicated up to this point in the array. Okay. So I'll just make dupe count. And this is going to be number of duplicates of current value up to same index in digits. This would be this thing. So I think this should be for every index range then. Streak is 0, dupe counts that starts at 0. If let's just start next one. If the value of the digits at this index equals the value of digits at the previous index, the streak is going to be added by 1. Else the streak resets to 0. And then dupe count dot append streak. Alright, the dupe count here is 0, 1, 0. I think that's correct. The first 0 has no duplicates. The first one has no duplicates. The second one has the first one has a duplicate, and the 2 has 0. This is trivial case. This is all zeros. Okay, let's put another test case here. Or modify this maybe. Let's put another test case. 1, 1, 1, 2, 3, 3. Is that trivial? 3, 6, 9. That's trivial, isn't it? Shucks. 1, 1, 1, 1, 2, 3, 3. Oh, okay. So yeah, the first one is 0 duplicates, 1 duplicate, 2 duplicates, 3 duplicates, 0 duplicates of 2, 2 duplicates of 3, 1 duplicate. Okay, that's fine. Okay, so dupe count is fine. So when you add a number, you multiply the number times +1, and also you divide the number. Don't divide by 0. Divide by 0 is a bad idea. By duplicates +1. Duplicates 1. Yeah. Divide by equals dupe count of this index +1. Okay, well, solve the 112 now. Does not solve this other one I made up. Okay, what's going on here? What is going? Well, actually, this is. I think what's going on is the fact that I've only really handled odd. No, this is odd count 1, 7. Okay, I was hoping this was just like me not handling even number of lengths yet. I still haven't handled even lengths, but this is an odd length. That is incorrect. Wait, why is this returning 0? This is an odd length. 4, 5, 6, 7. This is an even length. Oh, it's returning 0 because it actually calculated 0. Jesus. Uh-oh, SpaghettiOs. Okay, so sum here is 4, 6, 12. Half sum is 6. So it should be doing 0 to 6. 0, 0, 1, 2, 3, 4, 5, 6. Okay. Number of elements is 7. The length is 7, so it should do elements from 0 to 4, which it does. Okay. So 4, 6. So it should be doing 6. Should be doing 6. So it got to 18 using 3 elements. And it had 0 ways of getting 6 using 4 elements. So it needs to be 6 using 4 elements and 6 using 3 elements. Six using 4 elements. So it should be 1, 1, 1, 3. And there should be 4 ways of doing that. 1, 1, 1, 3. 4 ways of doing that. And then the other one is 3 elements getting 6. So it should be 1, 1, 1, 1, 3, and then the other one should be 1, 2, 3. And then there's 6 ways of doing that. Well, it did get 6 ways of doing that. Got 6 ways of doing that, and it got 0 ways of doing the other one. What the fuck? What the fuck? So it should be getting 1 way of getting 3 elements with a sum of 3. Is it not? So using 3 elements, the sum of 3, 0, 1, 2, 3. Why is this all zeros? Okay. The sum of 1 element. Okay. Okay, 1 element sum to 1, that's all 1s here, that's fine. The sum of 2 elements to 2, there's that looks good. Sum of 2 elements to 2. And then now the sum of 3 elements to 3, that is not great. Okay, so what is it doing here? Max sum greater than the value. Which it is, the max sum is 3. Part 1, not 0. So equals 3. Back sum so up to this index using should this be index minus 1? No. Value this index up to this index, one less element, back sum minus value. So the number of ways so there's one way of getting to index 2 with sum 2. So 3. Sum of 0, sum of 1, sum of 2, sum of 3. So one less element. So sum e is 2. Back sum minus value. So sum is 2 rather than 3. An index. Up to this point. So up to this point it should be 2. Zeros. 1. Sum is 1. Up to this point, adding 1. Up to this point, adding 2. Here. Sum is 1. Sum is 2. Is this actually hitting one of these two? Max of part 1 and max of part 2. Oh wait, what is going on here? I feel like this is actually feels like it's overriding this somehow. Like I feel like it's actually getting the right value at some point. If e is equal to 2, if e is equal to 2 and the half sum, back sum is equal to 3, print out part 2 e back sum. Like I feel like it's actually getting this correct, but then it's maybe overwriting it. No sir. No sir at all. No, this should be equals 3. So you're getting 3 1s, and the sum is 3. Nope, incorrect. So it is getting all zeros here. So why is part 2 this? Why is it going astray here? I mean, is it actually hitting this if statement? It is, it is. So it must be doing something here. Let's go ahead and do, so it's doing TP matrix of D is 2, back sum is 2. E is 2, back sum is 2, 0, 1, 2. So it should be getting 1. Why getting go down, go now 0? Okay, let's go ahead and just do this here. E back sum part 2 B matrix E minus 1 back sum minus value index values. Is it using zeros? Okay, it's getting 1 where I expect it to. Yeah, it should be getting 1s, yeah. So like 3 should be looking at the 1 here. So it's getting 1. 1 times is it just not calculating it right? 1 times part 2 plus 1. Okay. Yeah. I think it should be 1 times the length of the string times plus 1, where length of the string previously wasn't all that different than the actual value. No, it should be, yeah, it should be length of the string times 1. Length of the string plus 1. So length of the string should be the number of values in E. So E currently is 3. So yeah, I think it's times E. Yeah. Well, kinda yeah. Kinda no. Okay. Okay, so that made that back to 1. Does that not work? So that makes it back to 1. So 4, and this is 8. Let's say 8 times 18. 8 times 18 is 144. 180 minus 32, 36. Okay. But it should really be, well, okay, so this thing jumped up to 18. This thing jumped up to 18. Oh boy, what to do, what to do. So why did it jump so bigly? Okay, so What am I expecting it to be? I'm expecting it to be like 6 and 4. That'd be awesome. The number of ways where you pick 4 out of these numbers and sum up to 6. There's literally the only combination is 1113. 1113. So it saw that the number of ways where you pick 3 and get to 6 the number of ways you pick 3 and get to 6 is 6, I think. Up to the first 3 is 6. And now the number of ways you can get, if you add another 3 to the mix, if you add another 3 to the mix, it doesn't actually add any ways. Well, it shouldn't anyways. It shouldn't. So why is it getting 18? Yeah, it's multiplying 6 and 3. It's getting 18 back. This should just be 6 still. So what is it doing? Okay. So it's taking part 1, which is the number of ways that it's multiplying 6 times 3. The number of ways that you can get up to this point what is it doing here? Taking this 6 and multiplying with the 3 from so let's go ahead and print out some information here. E backsum index value. Alright, it's multiplying 6 times 3 here. So the number of elements is 3. The bag sum is 6. The index is 6. And the value is 3. Bag sum is 6. So that's the last row. The index is 6. So that includes all the elements. Value is 3 at that spot. Does this include all the elements? 0, 1, 2, 3, 4, 5, 6. Yeah. 6 is the 7th element, which is the last element. Okay. So if you have 3 elements and your bag sum is 6, so part 1 would take those 3 elements, that bag sum, and that index, that part 1 correct? So the number of ways to get 113, number of ways to get 6 out of everything up to that point using 3 elements is 6. That's correct. And then part 2, we multiply that 6. I see. I think I see. So the issue is I assume that because I'm assuming that the value itself is being used in the bag when you include the full number of elements. I think I'm assuming that. But if it's a duplicate value, then the count already includes it, and so it's not additional. It's not additional. So therefore it's double counting some stuff. So if you are dealing with a duplicate value, then you really can't assume that the new value is being used by all the ways that the previous value already counted. So what do you want to do in that case? What do you want to do? Hard to say, since I'm not even sure that I fully understand what the issue is. So what should it be? Well, the answer here should be 6. It shouldn't be 18. And the number of ways that you can do without this 3 number of ways you can do without this 3. I wonder. So the number of ways, part 1, the number of ways that you can go up to this point adding the number of ways you can go up to this point with this index. What does this even mean? What does this even mean? Like, you already have continue where it matches the bag sum. So up to the following index, getting this bag sum. Okay, so part 1 is just what the previous value, if you didn't have to use the current index value, is. The number of ways, basically ignoring the current. So that's like 6 already. There's ignoring the last 3, there's already 6 ways of getting 113. 1113. 1113. 6 ways of doing that. Wait, is that 6? Shouldn't that be 12? Oh, my screen ups up. The number of ways. We have 4 elements. No, it should be 4. What? It should be 4. Oh boy. No. One thing at a time. I'm dealing with the 3 element issue. So, okay, there's 3 elements, and those elements need to be 1, 2, 3. Yeah, okay, up to this point, there are 6 ways to get 1, 2, 3, and then you're dealing with this additional 3. And this additional 3, you think that you're multiplying by 4 and dividing by 3. Multiplying by 4. No, you're multiplying by 3 and dividing by 3. Multiplying by 3 and dividing by 2. 6 times 3 is the length, is 18, divided by 2 is the number, so it's 9. Somehow I got 18. Somehow I got 18. Yeah, so part 1, there was 6. Part 2, there was 3. Part 2 was getting up to two elements. The bag sum is 6 minus 3. So 2 elements, 3 bag sum. 2 elements, 3 bag sum. Two elements, 3 bag sum, 0, 1, 2. And so there's 1 way. Two elements. Bag sum is 2. No, 2 elements, bag sum is 3. 0, 1, 2, 3. So you get 2 there, and then 2 times 3 divided by 3 is 2. 2 times e, which is 3. Matrix minus 1, bag sum minus value, index. This looks identical. So number of elements is 3, bag sum is 6, value 6. No, index is 6, value is 3. am I putting it in the wrong spot? No, I'm not putting it in the wrong spot. So it's getting 1 from the matrix. And then it's multiplying that 1 times 3, dividing it by 2. Wait, what? 1 times 1 times e, which is 3. 1 times 3 is 3, divided by 1 at that point, duplicate count. No, divide by 2. 1 times 3 divided by 2. Alright, alright. I am kind of exhausted. This is going to be a to be continued. I'm definitely going to solve this before the deadline, but I should probably be taking a break. It's 4 hours.